Okay, Kipsters, today we're going to go ahead and just look over our geometry morning work. So you have an opportunity to look at that before you take your test. So looking at this, the first one asks us to find the circumference and perimeter. Circumference obviously talking about the distance around a circle. Our equation for circumference is pi times diameter. Our diameter here is not given to us, our radius is, so remember we need to go ahead and double that, so our diameter is equal to 8 centimeters. Plug that in, we have pi times 8, or we can just write that answer as 8 pi centimeters. Looking over here for perimeter, that's the distance around the shape. That means we just need to end up adding up all of this. 10 plus 4 is 14, plus 5 is 19, plus 5 more is 29, or excuse me, 24, plus 8 would be 32, plus 7 should be 39 centimeters. Let me just go ahead and check my addition there really quickly. 10, 4, 5, 5, 8, 7 is 4, 9, 14, 22, 9, carry the 2, 39 centimeters. Good. Alright, looking over here, now we're moving into the area portion. These are very, very basic area problems. We're looking for the area of a circle. That's pi times r squared. Here we're not given the radius, we're given the diameter, so we're going to go ahead and cut that in half. That's going to give us 5 centimeters for the radius. A is equal to pi times 5 squared. 5 squared is 25, so we have A is equal to 25 pi. And we can leave our answers like that, so 25 pi centimeters squared, since we're talking about area. Here we have a rectangle where we have length times width is our area. Area is equal to length times width. So that's going to be 3.5 times 4.2, 12.6. I'm going to have to go do that math off to the side over here. So 4.2 times 3.5. 0, carry the 1 is 21. 0 is 6. 12 is here. And we should get 0, 7, 4, 1. We should get 14.7 centimeters squared. Again, squared because we're talking about our units here. Here we have the area of a triangle. Area of a triangle is equal to 1/2 base times height. Our base here is 3, and our height is given as this altitude at this 90-degree angle. Remember, height always has to be at a 90-degree angle to the base. That's how we know our base and height. Height is 1/2 the base, 3 times 6. I'm going to group these first, 3 times 6, that's going to give me 18. Half of 18 is going to be equal to 9 centimeters squared. Now we move on to some irregular figures. Lots of different ways we can deal with irregular figures. The way I'm going to deal with this irregular figure is I'm actually going to do this as a negative space problem. I'm going to go ahead and make this one large rectangle and say that it's like this used to be shaded, and then there was a piece taken out of the center. So the original size would be the area of the original space was a 13 by 10 rectangle. 13 times 10, we see length and width here. 13 times 10 is 130. Now the negative space, this is going to take a little bit more thinking here. It looks like we need to find, we've got the length of the piece taken out, but we don't have the width. So in total, we're looking all the way from here to here to here. We see is 13, opposite side of that. So 13 minus the 6 would tell us that this width here is 7 centimeters. So length times width of our negative space is equal to 7 times 6, which is equal to 42. So our actual area is going to be, we started with 130 minus 42 would give us our final answer of 88 centimeters squared. Could have done that problem without negative space and broken it into several different rectangles. I probably would have suggested rectangles that were these three rectangles. And with those rectangles, we would have a 2x6, a 4x6, and a 4x13. So could have done that and then added it all together. Choice is up to you. Totally fine. Next one I'm actually going to do as an additive area, just like I suggested we could have done the previous one. I'm going to split it into two rectangles. Here, first one, I've got length times width. Area 1 is really easy. Five times 12 is 60 centimeters squared. Area 2 is this smaller one. Now, the entire length of this side is 9, not this small part that we need. So this part is 5, which means this part is 4. So our area 2 is equal to length times width, which is 3 times 4 is 12 centimeters squared. So when I add those two together, that's going to give me 60 plus 12, and gives me a total area of 72 centimeters squared. So we didn't use this as a negative space problem, we used it as an additive space problem. That's why we added the two areas. Moving on to the... Now we've moved on here to the volume portion of our work. This is a very simple rectangular prism here. So we know the volume of a rectangular prism is equal to length times width times height. And that comes from that basic idea of the area of the base, which we'll call, I'll just go ahead and call this the base, is length times width, so that's 3 times 2, and we'll call this part, for lack of better terms, the height. Doesn't really matter, remember, because it's commutative which one we label as which. 6 times 2, or 3 times 2 is 6, times 14, 14 times 6, oops, 14 times 6 is 4, carry the 2 is 84. So we get 84 centimeters cubed since we're talking about volume. Over here we have a three-dimensional shape. It is definitely not a rectangular prism, although it's clearly made of rectangular prisms. So I'm going to go ahead and split this up into two rectangular prisms. One here on the top, one here on the bottom. So this one on the bottom, I can see that's going to be a really easy volume to find. This one's going to be a little bit more complicated. But let's start with volume 1. Length times width times height is equal to 10 times 5 times 6. 10 times 30 is going to give me 300 cubic centimeters. And volume 2, so we have the height of volume 2. Now I need to know the width. Well, it looks like we've got the same width all the way across, so this is also going to be 5 centimeters. And our length is clearly not given to us. Alright, so this is obviously my mistake here. So had I given you maybe this over here and told you that this was 6 centimeters, then you could have discovered that this was 4 centimeters because it was front to back. So that's definitely my apologies if you weren't able to get that one. Just solving it, had we known that that was going to be 4 centimeters, we would have ended up 5 times 4, which would have been 25 times 4, which is 100 centimeters cubed. So that means our total area, our total volume, would have been 100 plus 300, which would have been 400 centimeters cubed. So sorry again that I did not give you one of the dimensions that you absolutely needed. My apologies. Alright, find the length of the missing side. So these are both right triangles, even though this one didn't seem to have a right triangle symbol in it. We could use a piece of paper to figure that out. Remember, our two legs make that right angle, A and B. So we're going to use A squared plus B squared equals C squared. It's totally fine. So 5 squared plus 12 squared is equal to c squared. It's 25 plus 144 is equal to c squared is 169 is equal to c squared, which means that 13 is equal to c. So our missing length here is c is equal to 13. And this other one over here, this one's a little bit different. We're given the hypotenuse here. So that one's going to be c, because it's not one of our legs, not part of our right angle. We'll plug in a squared plus b squared is equal to c squared. So we have 14 squared plus b squared, we don't know, is equal to c squared, which is 20 squared. It's going to be 196 plus b squared is equal to 400. I'm going to add a negative 196 to both sides. And gives me 400 plus negative 196. B squared is equal to 204. Got to do that last step. It's not 204 long. B is equal to the square root of 204, which is not a perfect square, so we'll just leave it as the square root of 204. However, we could figure out that that is between 14 and 15, because the square root of 14 is 196 and the square root of 15 is 225. So it'd be somewhere between those two. And the last one asks us to find the area of the figure below. So if we want to find the area of this triangle, we need area is equal to 1/2 base times height. So we have the base here is 12 plus 3.7. So that would be 15.7. It's this whole distance all the way across the base of our triangle. And we need the height of the triangle. Well, the height of the triangle is not given to us. However, we do see that there's a right triangle here that we can use to find that height. So I'm going to use this. This is my A. My B is my unknown, and this is my C. So I'm going to use A squared plus B squared is equal to C squared. A is 12 squared plus 13. Oh, sorry. B is my unknown. B squared is equal to C squared is 13 squared. So that's 144 plus B squared is equal to 169. Add a negative 144 to both sides. To 169 plus negative 144. Gives me that B squared is equal to 25, which means that B itself is 5 centimeters. So that gives us the height. B is equal to 5 centimeters. Now we can go ahead and finish up our calculation for the area. 1/2 of 15.7 times 5. So we have 1/2 times 15.7 is going to be 7.85 times 5. I'll go ahead and do that math off to the side over here. 7.85 times 5. 5 carry the 2. 2 carry the 4 is 39. 2 decimal places. And that's going to give us the area is 39.25 centimeters squared. So looking at that question, takes a little bit of extra work to find that base and height, but otherwise we're all good. So hopefully this is enough information to help get you through and get you studied and prepped using your morning work to study for your test tomorrow. So if you have any questions, feel free to give me a call tonight, and we'll hopefully see you rocking out that test tomorrow morning.